This video is for section 18.1 about rates of reaction. Learning goals are to express the rate of a chemical reaction and understand four factors that affect that rate. Let's take a look at that first learning goal. Be able to express the rate of a chemical reaction. The word rate is a measure of how much something changes in a specified amount of time. A common rate that we're all familiar with is the rate of speed, how far something travels in a specified amount of time. The reaction rate, or rate of a chemical reaction, is the change in the amount of reactant, or you could measure the change in the amount of product if you wanted, per unit of time. As an example, maybe the reactants change by 1 mole in 1 minute of time, and so the reaction rate is 1 mole per minute. If we're going to examine how quickly a chemical reaction proceeds, then we need to explain what conditions are necessary for a reaction to occur. And this is what collision theory explains. Collision theory states that atoms, ions, and molecules can react to form products if they collide with enough kinetic energy to form an activated complex. The activated complex is an unstable arrangement of particles that has an equal likelihood of forming a new product or reverting back to the original particles. So collision theory says that when particles are moving around and they collide, if they have enough energy, then the particles can stick together to form a temporary substance called an activated complex. The activated complex might become stable, creating a new product, or it can break apart, creating those original particles that were moving around. Another vocabulary word is activation energy. This is the minimum energy needed for colliding particles to form an activated complex. Just because particles are moving around because they have energy doesn't mean they have enough energy that when they collide, they'll create the thing called an activated complex. They have to have a certain minimum amount of energy to create an activated complex. An activated complex is an unstable arrangement of atoms that's formed if colliding particles have enough energy and the proper orientation. The activated complex is also called a transition state, and it lasts for a very brief amount of time. This is an extremely small number right here, just a tiny fraction of a second. For moving particles to collide and create the activated complex, they have to have that minimum amount of energy, called the activation energy, but they also have to be properly oriented when they collide. If they're not facing in exactly the right way, they're not going to clump together. They're just going to bounce off each other and keep moving. In picture A, we have this molecule, and this molecule moving around. Let's say they collide with sufficient energy and the right orientation that the two white circles will bond with the red circle. And these two white circles will bond with the red circle. That will create this new product. This thing in the middle is the activated complex. Now look at the second one. We've got the same particles moving around, and they collide, but not with the same orientation. And so they just break back apart into the same three particles that we had to begin with. In the first drawing, a reaction occurs. In the second drawing, no reaction occurs. Energy changes that are involved in chemical reactions can be shown with graphs. Consider the following two reactions. So here's our first graph, reaction number 1. The vertical axis is measuring energy. It's increasing as you go up. And the horizontal axis is showing the reaction progress. Let's say that we start with a bunch of particles that are the reactants and measure how much energy those reactants have because they're moving around. They have kinetic energy. So let's say that we measure that energy and it is at this height on the y-axis. When the reactant particles collide with sufficient energy, the activated complex forms, which then changes into the final product. The products have less energy than what the reactants had to begin with. Let's contrast that with reaction number 2. Here are some particles that are the reactants, and they have rather low energy to begin with on the y-axis. If energy is applied to those reactants such that the activation energy barrier is exceeded, then the activated complex can be formed, and from that activated complex are new products. In this second drawing, the energy of the products is higher than the energy of the reactants. The next learning goal is to understand the 4 factors that affect the rate of a reaction, or the speed of a reaction. First is temperature. Increasing the temperature increases the rate of reaction, and decreasing the temperature decreases the rate of the reaction. Can you figure out the reason? Increased temperature implies that the particles have greater kinetic energy. With greater kinetic energy, they will collide more frequently, and more particles will have enough energy to overcome the activation energy barrier. More of the activated complexes will be formed, which will result in more product being formed. The next factor that affects the speed of a reaction is concentration. Increasing the concentration of reactant particles in a given volume of space increases the rate of the reaction. Does the reason make sense to you? An increased concentration of particles means there are more particles that can collide. If more particles will collide, then more of the activated complexes will be formed, which can result in more product being formed. A third factor that can affect the speed of a reaction is particle size. Increasing the size of the reactant particles decreases the rate of the reaction. Decreasing the size of the particles increases the reaction rate. Here's the reason. Collisions occur at the surface of particles. So the greater surface area of particles, the more collisions will occur. For a given mass of particles, the smaller the size of the particle, then the greater the overall surface area of that substance is. Do you know what a Rubik's Cube is? You picture a Rubik's Cube. A single Rubik's Cube has a certain surface area to it. It'd be the area of all 6 of the faces. Now imagine breaking up the Rubik's Cube into the 27 smaller cubes that form the Rubik's Cube. Each of those smaller cubes will also have 6 faces. The total surface area of those smaller cubes is greater than the surface of the original Rubik's Cube. So when you split something up into smaller sized pieces, you're actually increasing the overall surface of the substance. With greater surface, there can be more collisions. With more collisions, there will be more activated complexes formed, which will result in more product being formed. The fourth factor that affects the rate of a reaction is whether there's a catalyst. The presence of a catalyst reduces the activation energy for the reaction. So that would increase the rate of a reaction. If it doesn't take as much energy to form the activated complexes, then it's easier to form them and more product can be formed. Here is a check for understanding question. I'll pause the video for you to answer this and then we'll discuss. The factor that's important here is the temperature. The colder temperature in a refrigerator decreases the rate of the reaction between the food and any bacteria that causes spoiled food. When food spoils, it's a chemical reaction between food and bacteria. So if you can decrease the speed of that reaction, then the food will last longer. This concludes the intro lesson about reaction rates. We examined the concept of rate of a reaction and looked at what it meant for a reaction to occur. That when reactants have sufficient energy to overcome an activation barrier, they form an activated complex, which in turn might form a new product. We also looked at 4 factors that affect the reaction rate. Adjusting the temperature, the amount of particles, the size of the particles, or the presence of a catalyst will affect the reaction rate.